Hey guys, BuildZoid here, and today we're going to do a session summary for the GTX 1080 FTW that I took on liquid nitrogen like 2 weeks ago. So that's great. I don't know why I didn't manage to do this video sooner. Actually, I kind of do know why I didn't manage to do this video sooner, but anyway, we're doing it now. I mostly remember the session. There's not too much to remember because GTX 1080s are just super easy to run on liquid nitrogen. So, yeah, if you're thinking about taking well, I guess these days nobody's going to have a spare GTX 1080. I'm so annoyed with the GPU situation. Like, if it weren't for all the freaking miners, right now you would normally be able to get 1080s at like under 200 quid. At which point, in my opinion, especially some of the nicer cards would actually be like really cool for just extreme overclocking and yeah, and also GTX 1070s for that matter. Like also just super cool cards for extreme overclocking, but thanks to the current GPU situation, 1080s in working condition go for around 300 quid, which is a bit much for, well, GTX 1080s as far as I'm concerned. So, um, yeah. Anyway, let's just go through all the scores that I did, and then we're going to talk a bit more about the actual, like, session and how, like, what's it like to run a GTX 1080 on liquid nitrogen. Though I'll spoil it right now. Very easy. It's extremely easy. It's yeah, anyway, we'll get to that later. So, scores that I took. So, I got the top score for 3D Mark Firestrike Ultra, so this is Firestrike at 4K. So I beat Miller for the top score there by a pretty significant margin. And I mean, partially because I am clocked way higher on the core than he is, right? Like if we look at his GPU clock right here, he's at 2054, and this is on liquid nitrogen, and he has like a proper extreme overclocking GTX 1080. So I don't know what's going on here with this score. Like maybe he just got really unlucky with the silicon, or yeah, I have no idea. But like this is a GTX 1080 classified, and my card is a 1080 FTW with a literal crater in the PCB. Like this this is still there. Right? Like there's not really much you can do about this. Like it's isolated because I removed all the power. Like you can see that it's isolated because that inductor over there isn't connecting this hole to 12 volts anymore, but yeah, so my card is obviously not doing that great on like its own level. It admittedly has a VRM that's actually the power board that I used is technically better than what the 1080 classified comes with in terms of just raw current handling capacity, but ultimately that doesn't matter. And e-powers are sort of notorious for losing overclocking headroom because you just can't get the kind of like voltage regulation and power delivery that from a VRM that you're like attaching, after the fact to the PCB than a VRM that's built directly into the PCB. Though I don't know how much of a problem that would be with a 1080 because 1080s really don't pull that much power. Even a 1080 Ti on liquid nitrogen has an average power draw of like 600 to 800 watts, and 1080s are a lot less than that. Like, yeah, the card's not power hungry, so I guess the e-power, like the e-power wouldn't have as much of a penalty in this scenario as it does on, say, some of the bigger cards out there. But anyway, so yeah, I'm pretty pleased with myself for managing to beat like this is a proper extreme overclocking 1080. Like if somebody asked me like BuildZoid, what 1080 would you take on liquid nitrogen if you didn't want to e-power it, and if you weren't e-powering a dead one, more like, if I had the budget to buy a proper 1080 is actually sort of the way to put it. Yeah, I'd buy a classified. I'd be looking for a classified or a Strix card. Maybe even the Zotac Amp Extreme 1080s, though that VRM is nowhere near the thing is, I would avoid the reference cards because the reference 1080s have like a 4-phase VRM, which honestly, like I'm actually pretty sure would fail if you tried to run it on liquid nitrogen, um, or, well, not ideal. Like, I really don't think that VRM is ideal, but at the same time, like, 1080s really don't pull that much power. And so the Zotac cards, which have like an 8-phase on them, those would be fine. Asus, if I remember correctly, has like a 10-phase with 60 amp power stages. The classified is a 14 phase using direct FETs. This is a monster VRM. This is the VRM that EVGA had on the 780 Ti Kingpin Edition, GTX 580 classified, GTX 680 classified, GTX 780 classified, 980 Ti classified. This is the classic EVGA 14 phase vCore VRM that they were copy pasting around across like the classified cards, and has a really really good VRM. So yeah, I'm really happy that like my card with a crater in the PCB is managing to outclock a like proper GTX 1080. Though I don't know, maybe Miller didn't have that much time to run the card, or I guess he might have not have been interested in like pushing it that hard. Like if you get first place, what do you really go push it to its limits? But yeah, I'm pretty pleased with myself on the whole, being able to be like an actual proper like not exploded GPU. Um, anyway, so yeah, Firestrike Ultra, and this is mostly just like core clock, though it is worth noting that I had to run LOD for this, and this is because Miller did as well. Without LOD, I was just about matching his score. And then when you turn LOD on, so that's this right here. So what LOD does is it basically reduces the texture resolution. And so if you compare that, if you look at Miller's score, like he has that warning as well, because due to the way HardwareBot runs their database, they allow people to modify the LOD. 3D Mark doesn't, because 3D Mark has different priorities for how they run their score database. So anyway, but yeah, like the LOD thing was like, this actually was a big part of the session, was me trying to figure out how to get LOD working. Because it turns out whatever version of NVIDIA Inspector I had was just not working for some reason. And so I had to find a new version of NVIDIA Inspector while I had the card on LN2. Actually, no, what I think I ended up using was NVIDIA Profile Inspector instead of NVIDIA Inspector. And that worked. So yeah, LOD is a huge deal, like, because I was like struggling to, well, I was basically like, I was basically matching his score, like slightly less. I was hovering around the sort of 7,000, like 6,900 something to like little over 7,000 points mark. Yeah, and then you put LOD on it and bam, plus 200 points, right? More GPU score than Miller has, obviously more physics score because he's on a 7980XE, and I have a 5950X, which is an absolute just beast of a CPU for the Firestrike benchmark. Honestly, like the biggest problem with the 5950X is the limited SLI support of the various AM4 motherboards. Right, like that's one of the main reasons I still want a 10980XE, is just like the 10980XE can do 4-way, whereas 5950X is really kind of can't, which is really annoying. Because I want these massive physics scores without like technically you can get the X299 chips to produce physics scores that high, but you need to take them on liquid nitrogen, and and they're hard to run. Like, those are not easy CPUs to run on liquid nitrogen. So it's just like, if I could get those scores without all the extra work, I'd really appreciate that. Yeah, so Firestrike Ultra, very like this is just a great result. I'm really pleased with that one, but it took me a lot of, like, way too much time to get LOD working, which is kind of frustrating. My excuse being I don't really bench NVIDIA GPUs very much. So yeah, that's my defense. And Firestrike Extreme. This was hard. This was really hard. Dart Mall here has an insanely high GPU score, like 14,740 points. I have no idea how he's getting that, especially because if we look at like his GPU clock here and his GPU clock over there, like at these clocks, this score doesn't make any sense. Now, if we check the actual 3D Mark monitoring, actually, no, yeah, it's 2316. So that score, just like, I have no idea how he's getting that GPU score. Like, is there some tweak that I'm not aware of, or like, what is going on with that? Because that is so freaking high. And so that took me so much effort. So Firestrike Extreme is actually the benchmark where I was running the highest core clock, because yeah, like Dart Mall, and I still wasn't beating him on the GPU score. Like, and the crazy thing is, like, I'm not really Like if I compare myself to some of the other GTX 1080 LN2 runs out there, like my efficiency seems fine, right? Like I'm comfortably beating 12 here, who's getting 13,639 points at 2379, right? And I'm getting 14008 at 2493. 12 is running more memory clock, and actually the memory clock situation is really stupid. For some reason, Afterburner only goes up to plus 1,000, and so like yeah, and I couldn't be bothered to find a different set up a different software utility to get more memory clock headroom, which is like this, like I hate software. I hate software so much. It's just like 90 all issues are caused by software. Anyway, I don't get how this score is getting this graphic score. Like how Dartmouth is getting this graphic score. I'm beating him on combined, which is mostly a GPU workload. With a 1080, like this is very much just a GPU workload, and so I'm comfortably beating him on combined. I'm destroying him on physics because this is a 6950X. But then the graphic score is like I just don't get what the hell is going on there. Like I don't, yeah, how does he have 700 more points? Now, here no, it says 2316. I don't get it. I do not get how at 2316 you can have 14,740 points. Like he's massively beating, 12 on GPU score. Again, no idea why. He's beating this score as well on GPU score, right? Like, and this is 2480 core, right? Like this is actually matching me for like GPU clock. And it like that's in line with sort of, but at much lower memory clock. And so, yeah, this sort of makes sense. He has similar core clock, but much less memory clock, and he gets a somewhat lower GPU score than I do. And then there's Dartmouth's score, which is like way less core clock, same memory clock, destroys me. I have no idea how. So, yeah, I don't know if it's like I'm just bad at benching NVIDIA or... Because the thing is, I have seen, and like I don't want to accuse anybody of this, but this is a thing I've seen with some of the cards even I have, where it's like I have a GTX 770 that scores way higher than it should because it black screens for very large chunks of the benchmark. And the benchmark just doesn't have any way of detecting that. I assume what happens when the card does that is it just somehow breaks the frame monitor. Like either it like just renders blank frames very, very quickly, and that like overinflates the score or something. But yeah, I have no idea what's going on with this GPU score. So this took a lot of effort to beat. I'd love to know how you get 14,740 out of a 1080. Because like I don't know, it can't be a CPU bottleneck. This is a 5950X. Like the 5950X is literally being used for the like Firestrike extreme world record with the 6900 XT. So it is not a CPU bottleneck, right? Because if it was, the 6900 XT would be complaining about being used with a 5950X. So yeah, I don't know. Maybe there's some weird obscure software tweak that you can do or something to boost GT1, but like, I mean the graphics tests. But yeah, I don't know what's going on there. I wish I did though. Either way, I managed to beat him with just brute force on the CPU side of things, right? 44, like way more CPU score, more combined. And so even with the much weaker GPU score, I did manage to get first place. But yeah, I'm annoyed about this one. Like it's just like, because if I knew how to get that, like that is such high efficiency. Like if I had that same like core clock to GPU score efficiency, I'd be at like 15,000 points with my settings on the card. So yeah, for like I'd be at like 15,000 points for the GPU score, which would put me over 14K overall. So yeah, like I wish I knew what's going on with that. Anyway, the next thing is of course just regular good old Firestrike, and here I had to beat Kikun31, who ran with a 5950X on phase change. So for once, somebody who actually is beating me. So here it's not about me having a bigger, faster CPU. That's fine. My GPU is a lot, yeah, Yeah, I have quite the GPU score advantage. A whole like almost 1,000 points. So yeah. Also, I really need to figure out to like the I want to rebench that 1080 because there's a few benchmarks that I didn't get top scores for. When I rebench it, I need to figure out well, something other than Afterburner for the memory clock, or figure out how to get more memory clock range in Afterburner, or I think Precision actually has more memory clock range. Like I think EVGA's Precision software is actually really good for 10 series. I don't even know. The thing with Precision is like and I know, you know what bugs me with a lot of these overclocking utilities? How they try to have all this extra unnecessary functionality. I need a memory clock slider and a core clock slider and nothing else. I don't want no OSDs. The Afterburner always pops up with that Riva tuner statistics server thing. It's just like, go away. I want to change the clocks. Like if there was some way to just directly tell the NVIDIA driver to change the clocks from like command prompt or something, that would be ideal. Um, but anyway, so yeah, so this is very simple. My GPU very fast because my GPU on liquid nitrogen. This is actually not maxed out. This isn't even close to maxed out. This was before I realized I can just max out the afterburner slider because I was struggling with some weird instability issues earlier into the session. And so this like the order in which the benchmarks went was like basically I took Firestrike, and then I actually no I think wait, where is it? So I think it was I took Ultra. No, it was Firestrike. Then I did Ultra, which is Ultra is when I realized, wait a minute, I can run max memory clock. And then I took Firestrike Extreme, which is here I really had to max out the GPU. Though admittedly, I think Extreme's a little bit easier for the card to run than Firestrike Ultra because Ultra is 4K, of course. Um, but anyway, and then regular Firestrike, this is sort of the like because the thing with regular Firestrike is like even without LOD, even without like which ultimately the final score was with LOD. Yeah, without LOD, without anything, like just being able to hit 2400 core is already enough to just sort of take the first place in this. Not by such a large margin, but you know, yeah, I could already take first place with um without resorting to like without running LOD and whatever. Like I could just brute force clock speed for this one. Anyway, so yeah, I took Firestrike. So this one's sort of just like yeah, this was one of the first scores. So I guess I could redo this and do it better. There's maybe a chance that Firestrike would actually work at 2500, which none of the other like Firestrike Extreme won't. Firestrike Extreme's heavier. At least I think it's heavier. Anyway, so yeah, I took Firestrike, then Time Spy. Time Spy was kind of easy. Right, 2442. I don't think this is even maxed because the thing is, I'm pretty sure Time Spy GT2 Time Spy is pretty hard on the card in terms of load and everything. And so I think after I took all the fire strikes, I switched over to Time Spy and I basically just dropped the core clock by some random amount that I was like, yeah, this will probably work. And then I ran it. And I think I did end up raising it a little bit. I think I dropped it down to like 2400 initially and then, walked it up a little bit more. Um, but yeah, so Time Spy was pretty easy because the previous top score is from a card on single stage phase change. It's really surprising that on single stage you can get 2350 running. Like that's really like that's not far off of what I'm running on LN2, though the problem that I've heard from so unfortunately 1080s aren't like super heavily explored on LN2 unlike 1080 Ti's. Like 1080 Ti's have been benched to death on liquid nitrogen. Admittedly, but by only a couple of people, like have more people than 1080s. Like the funny thing about hardware bot is most of the competition is concentrated around the really expensive parts because those get the world record points, right? So um, like having so even like at the end of the day, to me, benching a 1080 or a 1080 Ti is kind of like, well, you're still just moving clock sliders around, so it's not really that different. It's just that the obviously top score in Firestrike overall, like fastest single GPU Firestrike at the time in general, you have to do that with a 1080 Ti. You can't do that on a 1080. So that's sort of why you have a lot of like, so 1080 Ti's actually seen much more action on liquid nitrogen than 1080s did. But at least the limited discussion of 1080s that I've heard is basically these cards have voltage scaling issues. And I can basically confirm that with my card. Like on my card, I saw the same. It's just like where on 1080 Ti's you can go up to like 1.6, 1.5, like 1.5 to like 1.6 volts on the core. 1080s, you can't. They basically don't work at those kinds of voltages. Like they turn completely non-functional. Um, Horrible instability, and that's actually where the oscilloscope came in really, really handy. So this was actually the first, actually no, second GPU benching session that I've done using the oscilloscope as a glorified multimeter. Well, no, which is what an oscilloscope is. So no, I was using the oscilloscope as an oscilloscope, and man, it is really helpful for seeing some of the things that you just won't see from the FPS readout, and we'll get to that. But yeah, so time spy, yeah, phase change. Yeah, so the thing is, like, the cards actually, like, getting into the 2300 range, very easy. Going much past that, honestly, still pretty easy for me on liquid nitrogen at least. But then you just hit a brick wall with voltage, where it's just like you can raise the voltage and things just get worse instead of better. And it's not immediately obvious that they're getting worse either. It's honestly like the cards are a bit weird. Once you start, yeah, at high voltage, the 1080 starts giving you like 6900 XT vibes, except nowhere near as bad because it can still render the desktop somewhat reliably. Anyway, yeah, so Time Spy was, rather easy because I don't really think there's much competition on Time Spy on liquid nitrogen in general. Oh, there's a 2455 on single stage. Is it because I have way too much CPU? That's a 10900K. I'm like way ahead on GPU score, yeah. Also for Time Spy, it's not LOD. That's worth noting. Time Spy is, for Time Spy, this is like no weird driver tweaks. Like this is the benchmark rendering as it should be. Other than, of course, any artifacting, because, hey, as long as it finishes the benchmark, it counts. Anyway, so yeah, I'm actually surprised. I guess this score might be an example of what we'll get into later into the video about, like, mashing voltage into these cards does weird things to them. But, yeah, so solid result for Time Spy. I also took Unigen Superposition 1080p Extreme, and there's even less competition for this benchmark than there is for Time Spy, which I think is a real shame because Superposition this doesn't have a CPU component, right? So this is this is a pure GPU benchmark. And one of the things that, I think a lot of people find frustrating about benching GPUs on hardware bot is that's just like, well, actually, if we get to the 1080 rankings, so like this is Firestrike, but it's overall score, not just GPU score. So you have to have a good CPU. Oh, I also tried to do CloudGate. Turns out CloudGate is super CPU bottleneck. Actually, no, it wasn't. No, I think it was CloudGate. Yeah, so this super CPU bottlenecked. That would require probably like a 10900K on LN2, which is actually what I'd like to run the card with in the future. Yeah, because I think with a 10900K on LN2, you could get like way higher average FPS over there, which would be kind of fun to see. And also because with the 5950X, you're just running 16 cores, 16 threads. And with a 10900K, you can run 10 cores, 16 threads, which with like the really high clock speeds that you can reach on liquid nitrogen might actually give you an advantage for CloudGate because it just runs at such high FPS. But anyway, yeah, so I tried CloudGate, that didn't go well. It's a horrible, but yeah, so this is like technically like it's not just like you won't win it. I don't think you can take the first place in that with a stock GPU, but you do still need kind of a ridiculous CPU overclock. These have a very significant CPU component. I don't bench these. Actually, I think these are entirely CPU limited. I guess we can just click on one of them. And yeah, 6.3 gigahertz, 9900K, that tells you all you need to know. And you'll see like there's a lot of that basically. So Time Spy with the 1080s, not that CPU limited, but there's still, like, the CPU score is a big chunk of that benchmark. Time Spy Extreme, actually, I think on the 1080 this is probably just a GPU benchmark. Not entirely sure why I didn't bother running this. Because this would have probably been worth running. It's just Time Spy Extreme is not a benchmark I've really run at all. So, you know, when you're on liquid nitrogen, it's just like you want to run the test you run. Also, it's only 29 points. Yeah. Then we have like Vantage, which has a very, very significant CPU component, especially with GPUs that are this fast. 3D Mark 03. Yeah, this is a CPU this is a CPU benchmark, 7 gigahertz, 7700K. So yeah, then you have like 3D Mark 11 performance, which very significant. Like not like this does care a lot about the GPU, but at the same time it has a very significant CPU component. This is a lot like Vantage, except it scales to 32 threads. If anything, that makes it worse, because you need much. You know, you need a potentially even bigger CPU for it. Heaven Extreme, unfortunately, once you're in that like 8,000 points range, super CPU bottlenecked. You need at least like a 6 gigahertz Intel chip for this kind of thing. Yeah. And this is a 6.6 gigahertz Intel chip. So, yeah, that's kind of the thing. So I really like superposition is cool because you don't have to worry about your CPU performance for it. And then, you know, 8K optimized, I guess I could have done the same thing there. Anyway, so yeah, superposition really like it's great that we have this like super GPU limited benchmark, but unfortunately not that much competition on LN2, and also this is a benchmark where LOD is allowed. So if you go to the rules, and this is how you know like if you're getting into hardware bot for any benchmark, you go to the the benchmark section, and then oh come on, oh wait, the rules are right there. Yeah, so. Yeah, verification link required, LOD tests allowed. And the reason why these are allowed is because there's no way to prove that you didn't have them turned on. It really is that simple. It's just like, yep. Because like tests, you literally just go into the AMD driver and you turn off tessellation, and superposition won't tell you, hey, you turned off tessellation. And LOD is the same thing, except you need like NVIDIA Profile Inspector for LOD, which is arguably a bit more difficult to deal. Like it's not really that much harder to set up. Like it, yeah. And and then once you have LOD, same thing. It's just the benchmark doesn't tell you, hey, you have LOD on. Whereas like the 3D marks detect that, so that's why like Time Spy doesn't let you run LOD. Though the Firestrike didn't used to, and that's why. Anyway, that's like a topic for a separate video. Yeah, so 3D Mark 11. This is a benchmark that I was like, oh yeah, I'm gonna do 3D Mark 11. I'm gonna get so many points. It's a 50 pointer. I'm gonna run my card and take 3D Mark 11. Turns out 3D Mark 11 really hates Ryzen CPUs, like a lot. So I was getting like a great physics score, and I was down, I think, 2,000 points on GPU. And honestly, it's kind of stupid that I didn't save the score anyway, because I would have still had a decent amount of, I would have had a decent amount of points from this, even if I wasn't like, even if I only had 32,000 points overall, which I didn't. I think I was in like the low, mid 33,000s or something. But yeah, it was way down on GPU score. Combined was somewhere around 25,500, I think. So, and it turns out like freaking 3D Mark 11 just isn't a big fan of Ryzen. So yeah, even a 5.125, 5950X here, and he like Kikun is down like 3,000 points against the top score. Yeah, huge physics score, which was the same for me. Like physics was great. His combined isn't anywhere near as bad as mine was. My combined was just awful, which I think might be down to the fact that he just has a much higher CPU clock, so less of a CPU bottleneck. Also, a very different approach to the memory settings, so that might be part of it. Because I was running dual rank G-Skill, Ripjaw's 5 DIMMs, and so I didn't there's no way I was hitting these kinds of memory settings. So yeah, so I want to revisit 3D Mark 11 with a 10900K. Because a 10900K on LN2 is just going to destroy this benchmark. Like, Yeah, so I need to do that. Also, I'm thinking 10900K on LN2 instead of trying to push the 5950X really hard because pushing the 5950X is way more fiddly than pushing a 10900K. Like a 10900K on LN2 is actually a really well-behaved CPU. Um, and so, yeah, I think like that. I think is like the path of least resistance. Within the admittedly, I do have the advantage of having a really huge variety of hardware to choose from, and out of the stuff I have available, 10900K seems like the best option for this because with 10 cores and 16 threads, it's still gonna get a decent physics score, but it should massively help the GPU score because this benchmark, like, it runs at high frame rates and it doesn't like Ryzen for some reason. So I would assume it's mostly like an Intel CPU thing. Like it should appreciate the 10900K a lot more. And then combined score. I mean, if we just look at Nick's score, because I think this is a 9900K or a 10900K, if I can't remember right now. Yeah, 5.4 gigahertz 10900K, and yeah, like the huge GPU score compared to the Ryzen results. So that's kind of the thing, is just like, admittedly, his GPU's also clocked way higher, but like I wasn't catching up to this. Like I wasn't even close to catching up to this, and I was also struggling on combined. So yeah, for 3D Mark 11, 10900K on LN2. Because you can take that CPU to full pot with the Maximus 12 Apex. It's a super easy CPU to run on liquid nitrogen. Um, Actually, maybe I'll use the Tachyon for it, just just to try out some different boards. I have both of them prepped for LN2, so it doesn't really matter which one I choose. Anyway, yeah, so 3D Mark 11, and I also ran Vantage. Wait, did we go over Vantage? Oh, yeah. So I somehow managed to skip over 3D Mark Vantage. We did superposition 3D 11, and so Vantage, man, Vantage is a similar situation where it's just like, well, actually, Vantage is Vantage is older than 3D Mark 11, and Vantage is so CPU bottlenecked. It's insane. Like it's so CPU bottlenecked. Like it is ridiculous. And it's not even like the CPU score is fine. It's the GPU test that is like, there are parts of the GPU test where the card just so bottlenecked. Like it's insane. Like you wouldn't think a 4.85 gigahertz 5950X would have issues, but no, it does. And it's like the something about this benchmark just doesn't play super well with Ryzen. And so I ended up second place because, admittedly, like for Vantage, Kikun also used a 5950X, but he just clocked it way higher than I did, right? So he's at like 5.1 on single stage phase change. Mine is on an AIO, and so I'm stuck at 4850 on the cores. Actually, that's only on like the best CCX. The second CCX is, I think, at like 4750 or something. Um, and so, yeah, you know, like you can see the bottleneck, right? Like he's getting 95,343 GPU points. I'm getting 95,955 GPU points. Like, there is almost no difference between my GPU score and his GPU score, even though I am like way up there on the GPU settings, because I'm just so CPU bottlenecked for this test, right? Whereas he's still CPU bottlenecked, just less so, right? And you can really see it in GT1, right? Like I'm getting 261 FPS on average. He's getting 272. He's literally getting more FPS than I am at less core clock. Way less core clock. Now on GT2, I have the advantage because GT2 is a less CPU intensive workload. But yeah, GT1 is really not thrilled about the whole 5950X situation. So this is another benchmark where it's like 10900K on LN2 would be really, really, like 10900K on LN2, and I think the GPU will put out over 100,000 points in the GPU score, which would be really cool to see. I'm not sure if anybody's gotten a 1080 to do over 100,000 points. Like, I think that should have been done because it's definitely doable. And people must have been benching these chips, like these cards, with Intel chips in the past. What's this run with? Oh, this is a 7960X. Yeah, X299 is like is almost as bad as Ryzen when it comes to well, X299 sometimes has an advantage, but yeah, the thing is there's a lot of people who are just carrying the CPU score. Yeah, so here we have like a 7920X at 5.4 gigahertz, and it's losing to the other scores because of the CPU score situation, but yeah, more GPU score. And that's at just 5.4 gigahertz. So with like a 6 also, this is just 12 cores, 12 threads. So a 10900K running 10 cores, 16 threads, because Intel has the whole you can disable hyperthreading per core, is going to absolutely shred Vantage. So I still need to do that with the 1080. Don't know when I'll get around to doing that, but I do want to do that because yeah, there's still a few benchmarks that I haven't taken. So I'm just going to go and use, like, obviously I still want to max out the GPU with it. It's not like I'm going to take it easy on the GPU. Like, I'm going to run it at over 2400 at the very least, but yeah, need to revisit things like Vantage and 3D Mark 11 because the 5950X just doesn't play well with those benchmarks. So that's the scores, and that took me 36 minutes. Damn. Anyway, let's talk about the actual session. Luckily, I don't think there's that much to talk about, right? So here's the start of the session. You can sort of see the, well, you can't really see the insulation setup. We'll get to that. So yeah, here's the start of the session. I'm actually using the oscilloscope for monitoring the core voltage. I think I have a decent picture of that somewhere. Let me just find it. Ah, yes, here we have it. So there we go. So right there, see that? That right there is a coax. Like, that's the coax going to it's not soldered to the back of the card. There's a little connector that I soldered to the back of the card. The coax plugs into that. And yeah, that gives you just, like, this is so awesome. Also, with the 1080, you need to insulate your motherboard. Like, you really need to insulate your motherboard. Now, some people might be like, why don't you run like a backplate heater, which I have one now. And the reason for that is very simple. GDDR5X, the memory that's on a GTX 1080, is made by Micron, and that's not really that important because all of it is made by Micron, but either way, this GDDR5X memory scales with temperatures. So the colder it is, the better it clocks. And so you actually want your card to look like this. Honestly, it might not even be a bad idea to try, like, add some kind of, like, thermal interface between the memory chips and the LN2 pot. Like, that might actually help memory overclocking even more so, but just letting the card freeze through like this actually helps with memory clocks. So, yeah, if you're going to be running, and this is true for like 1080 Ti's as well, and 1080s, 1080 Ti's, all the GDDR5X cards, like, you don't want to keep the memory warm. You want the memory to be as cold as possible. And so this is a really good idea. This right here. And consequently, you also need to insulate, like, the motherboard. So that's why my B550 Vision has a bunch of plasti dip around the PCIe slot, as well as on the back of the PCIe slot, because when the back of the card looks like this, the actual PCIe slot also freezes through. Like, there is ice on the back of the motherboard when your GPU looks like this. And actually, this is not even close to the end of the session. So yeah, it would, and by the end of the session, after 4 hours, card was very, very frozen. So yeah, and also, yeah, it was a 4-hour session, and the GTX 1080 is just so easy to run on liquid nitrogen. It's great. It really is a super convenient card to run on liquid nitrogen. Like, 10 out of 10, would LN2 again. I also want to get a 1070 for the same reason, and of course I have a concerning number. Well, no, 1080 Ti's I still have a sensible number of. It's the 7970s that are concerning. Way too many of those, but yeah, I still, like, I have 3 1080 Ti's. I have one 1080. I had a 1070 in the past. I wasn't, like, that didn't, like, I ran that on LN2. It wasn't really, like, I want to revisit that. Because I can do it so much better this time. I can hook up the oscilloscope to it. It's just gonna, and also I need to get a 1070 with a better PCB layout, because the one I was using at the time had a bunch of capacitors that got in the way of the LN2 pot, which, Yeah, was really inconvenient. But anyway, where was I going? Yeah, so insulation wise, I mean, so the towel over the HDMI cable, this is because actually when the card freezes through like that, like even the HDMI cable freezes over, everything freezes over. Honestly, also I totally underestimated how much cooling capacity the just like evaporated, the boiled nitrogen still has. So the cold nitrogen gas spilling out of the LN2 pot, how much cooling capacity that has because and I don't think I have a picture of this. Um, yeah, I don't think I have a picture of the actual problem itself, but eventually I ended up setting up a sort of like air barrier. Because the thing that was happening was actually my power and reset buttons were freezing over, which was not convenient. So here's sort of later into the session, you can see, yeah, I have another towel in front of the card to just stop the cold from spilling directly onto the power and reset buttons because those were freezing over. Um, yeah, card goes to full pot, and then you just sort of sit at full pot for 4 hours. I didn't have to heat it up once. Thermal paste was the Thermal Grizzly Cryonaut Extreme. It held up great. I did use quite a lot of it. Actually, I'll show you the application right now. So, yeah, so basically what I do is I spread a bunch of thermal paste on the LN2 pot. So that's why, it just goes everywhere. And then also I put like a big old glob directly onto the card itself. Yeah. So really, just yeah. So a lot of thermal paste. And that generally like it helps a bit with thermal transfer. It also seems to help with cracking in my experience. And also I'm like the thing is I've not run anything like I don't know if 1080s are particularly prone to thermal paste cracking. 1080 Ti's are. I know that for a fact. So, I need to run a 1080 Ti on this stuff some days to see how like to get a really like good test of how stable the paste is. But on the 1080, like no issues. 4 hours, and at the end of the 4 hours, it was hitting the same clocks that it was hitting right at the start of the session. Actually, it was doing better because I figured out how to run the card. Um, but yeah, so here's the thermal paste application. Then the actual on-card insulation itself, other than all of the towels, is of course Plastidip. And the reason I use Plastidip for insulation is very simple. You can pull it off afterwards. Now, you do have to be a bit careful with it around the memory chips. If you get a lot, like if you apply a lot of Plastidip around the memory chips and a lot of it ends up in the VGA, and you just kind of rip at it, it's going to destroy the BGA. And then you're gonna be screwed because you're gonna have a dead like you're gonna kill the like you're gonna basically gonna have to replace the memory chip if even that is going to help you, and that might not. So yeah, that's the one downside to this. But unlike Vaseline, this isn't disgusting. Right, that's basically why I use it. Like, yeah, I can peel it off if I need to, just need to be sort of a bit careful with it. I also would prefer to use colorful Plastidip. Well, it depends on what I'm doing. Like colorful, it's easier to tell. Like you can see around the memory chips, it's actually lifting off on its own. And also, I didn't insulate all the way to the like ground connections of the e-power over there because I want to be able to desolder the e-power. And unfortunately, like these wires are porous, so you can't really Plastidip too close to those because it'll like soak into them, and then desoldering those wires is gonna like yeah, I don't want to be smelling burnt Plastidip. Probably not good for you. Um, yeah, on the rest of the card, you just sort of like I just use a paintbrush to apply it. So you take the paintbrush and just do like one thin layer, or well, relatively thin layer. But that's like the nice thing with the colorful ones is it's easy to tell how much you have applied. If you can still see through it, it's relatively thin. The one downside to the colorful Plastidips, and this blaze orange one doesn't seem to have too much of an issue with this, but some of the glossy, like colorful, a lot of the glossy colors have a tendency to peel. Especially, I think like the tangerine orange is really, really bad about it, where it just lifts off on its own. A lot like what I have around these memory chips, and this basically happens if you apply too much too quickly. So, yeah, don't do that. Because what happens if you apply a lot of it as it dries out, it starts to contract, and as it contracts, it lifts it like it pulls itself off of the PCB, which is why you end up with that. So you can avoid this. There's also some Plastidips like black doesn't really suffer from this too much, or at least it's not visible. I'm actually black will still do this if if you screw up, yeah, you can get even the black plasti dip to do that, but you won't be able to tell, so you'll feel better about it. And with the clear plasti dip, you can definitely see it. Clear makes it super obvious when it's happening, but it doesn't it sticks a bit better than some of the colorful ones. And the blaze orange actually really works quite well. So I'm actually really happy with it. I was kind of worried when I got 750. Like, unfortunately, they only sell blaze orange in really big like cans, but like it's peeling it off of this 1080 went really smooth. I did peel all of it off because the card's back on air cooling for a bit. Um, and so if I'm pre-testing it, I don't really want the memory chips to be insulated, considering that they scale with temperature and that kind of thing. Um, but yeah, also there's some adjustments that I might want to make to the card. So yeah, I've pulled all of the plastic off of the card at this point. Um, but if I want to reapply, like, and that was like, and it came off easy. So yeah, I like plastic dip. And also my favorite part of it is like if you do it right once, you can leave it on there like forever. I have some motherboards that I've literally dipped once and never again, and you can just run them and run them and run them and run them and don't have to worry about ever insulating them again. Um, so yeah, so that's sort of why I go with Plasti Dip instead of Vaseline, because like if I really need to, well, it's not even really need to. If I need to get under it, I can peel it off, and unlike Vaseline, it's not disgusting. Um, and also, if I don't need to peel it off, don't have to worry about insulating at all. It's just like if you did it like if you do it right the first time, you can just keep using it. Now, this obviously isn't right. Like I left those memory chips, naked on purpose on one edge because it's just like I don't want to go all the way to there. But the thing is, that's what the shop towels are for. Like there's sort of two factors to the insulating with condensation. Is that basically if you restrict airflow to a certain area of the card, you're not going to have condensation there, right? Like because you just won't, right? Like like you can see that there's like one or two droplets of water on this, and I think this is right after the session. In fact, I think this picture is right after I pulled the LN2 pot off of the card. So the card's probably still slightly below ambient temperature at this point, and it's dry except for, a couple, dots of water. So obviously I'm not too fussed about this area as long as like that area is properly restricted from airflow. So yeah, and then I also just had some tape over the V-core edge of the E-power because some of these wires that I have for ground go really close to it. So yeah, didn't really like the thing with the E-power is it's not that it would shut down if there was a short circuit, it's that it would like it would just burn the short circuit down or do its very best to do so. So yeah, don't really want that happening. So some electrical tape just to cover that up. Um, anyway, yeah. Oh yeah, here's the rear of the card, and this is why you want to. Yeah, I didn't do that great a job. Like this is after I pulled off the towels. It's just completely covered in ice, but ice is fine. It's liquid water that causes issues because liquid water is electrically conductive. Ice isn't. Um, Ice is fine. Ice is completely fine. So water, on the other hand, massive problems. So yeah. Anyway, oh yeah, here's the back of the card at the end of the session. Yeah, frozen all the way to the VRM, so you can see some more of the plastic dip on the back there a bit. There's the coax, and yeah, like this is what it looks like after 4 hours. With actually, you can just barely make out, like there's capacitors, and actually I think this is the mounting hardware. There's like a capacitor over here. Actually, yeah, there's capacitors right over here. That's that middle bulge is some capacitors. And you can see the power bridge is completely frozen over as well. I didn't insulate those. My logic being that they're so far away from anything that it shouldn't really be a concern. I did put a little bit of tape around them in areas where I was like, oh, this is coming kind of close to something that's grounded, because those are V-core. So one of them passes really close to the to one of the mounting thumb screws. No, thumb nuts. Yeah, one of them passes really near one of the thumb nuts for the LN2 pot, and so that area got a bit of tape. But other than that, I mean, it's ice. I'm not too concerned about it. What else is there? Oh, here we have another like top view. Yeah, Yeah, card no power connectors. Because the thing is, the way the card is set up is all of the power on the card is jumped. Like actually, so the only power delivery still left on the card is like the PEX rail and the memory VRM. And so that all runs entirely off of the PCIe slot. So you don't need to plug in the 8-pin power connectors on the card because I've rewired the card so that it doesn't need power connectors. And so only the e-power, and actually I even modded the e-power so it only needs 6 pins instead of 8 pins. Nor like it's set up for 3 8 pins, but yeah, I've modified it so I don't have to plug in all 8 pins in because the like split 6+2 pin power connectors are so annoying to deal with, and when you have 3 of them, it's just like I'd rather not. Um, anyway, so this is from towards the end of the session. I actually completely ran out of LN2 at the end of the session. Like I actually went through all my LN2 right as I was finishing up my last benchmarks. Um, actually, not completely. I think there was like a leader still left in the doer, but I don't have like an extraction system for the doer. So if there's a leader at the bottom of it, I'm not really getting it out. Or maybe less than a liter. I'm still not getting it out. Like whatever's left at the bottom is not coming out unless I tip it all the way upside down. And it's just like I'm not like, trying to aim that into a thermos is just not really happening. So you don't really want to be running benchmarks on that. Have any other good pictures? Oh yeah. Here's another angle of the card. Very frozen. This is actually running Time Spy, and so obviously it's like boiling off a lot of nitrogen, which is why we have this whole sort of like waterfall effect of just water vapor condensing out of the air where it mixes with the freshly boiled nitrogen from the LN2 pot. There we have the oscilloscope. This is super handy, by the way. Oh, also the Elmore Labs KTH thermometer. So this is a nice little K-type thermometer. Works really well. Runs off a USB. Unfortunately, I was originally planning to use my multimeter for monitoring, and then for some reason that stopped working properly. That multimeter, considering how much it costs me, has a lot of firmware bugs. It's really annoying, actually. But anyway, so yeah, the multimeter decided to get one of its typical firmware bugs. So I had to quickly pull this out and plug that into the oscilloscope for power. But that works great, and it doesn't take up that much space on the desk. And then the oscilloscope is just measuring the core voltage. Yeah, not doing too bad on peak to peak, right? 230 millivolts. That's about what you'd expect from a stock NVIDIA GPU. Actually, no, that's better than what you'd expect from a stock NVIDIA GPU. Honestly, NVIDIA power delivery is just, how NVIDIA GPUs can even function, is difficult to understand. But yeah, quite a lot of undershoot there, even with all the extra capacitors, but at the same time, the card's pulling a lot more current than ever before. So, yeah. Average voltage of 1.32, max voltage of 1.42. So, yeah, and the reason having the oscilloscope for monitoring the card like this, because the thing is, it's not like I have load line settings on the e-power so that I can like tweak the V-droop to try get like better peak-to-peak results or anything like that. It's not what the oscilloscope is helpful for. No, what it's helpful for is catching dropped frames. So the interesting thing with the GTX 1080 is if you keep mashing core voltage into it, eventually it starts getting really unstable. So instead of like getting more and more core clock out of it as you keep increasing core voltage, what starts happening is it starts not rendering frames. And that translates to like really bad benchmark scores, even though the benchmark still finishes and you can like run the benchmark at higher clocks than ever before. You get your basically your scores get worse. And you can't really like the thing is when the card is rendering like 60 frames a second, you're not going to see one missing frame. Right? You're not really going to notice it. And the thing is, it's also not really one frame, but it's not frequent enough that you'd start noticing, hey, this card is like very, visibly black screening the output. So it kind of looks like, the benchmark runs and then your score's bad. And it's like, why is the score bad? And then if you have the oscilloscope, you can very clearly see it's like skipping frames. And that's actually what's trashing the score at high voltages. So yeah, like early into the session, I actually ramped the card up to quite high voltages on the V core. I was all the way up at, I think, like over 1.5 volts. and that's idle voltage, not load voltage, because there's like the e-power has a bunch of V-droop programmed into it, and yeah, there's no like droop settings on the board, and I didn't really feel like hooking up the USB 005 to it or the EVC to it, which like I could have, but I didn't really feel like doing it. Um, Also, like I'm not sure, like I'm the thing is like I have the scores I want, and maybe if I spent forever fiddling with the voltage control settings, maybe messing with like setting up forward voltage sense or not having like, because currently I don't have forward voltage sense on the card. I could set that up. I decided I don't need it because I don't really have that much voltage drop to begin with. Like the gap between my set voltage and my average voltage is I think 80 millivolts or something like, or 100, something like that on LN2. At ambient, it's even less than that. It's like 50 millivolts. Um, but yeah, and also the issue is like there's quite a lot of E-droop from the E-power itself. Like the E-power dips like 50 millivolts on its own. So um, maybe what I'd do would not be so much like uh, do forward voltage sense and keep the same level of load line, but like remove the load line and leave the power plane impedance in place. Because that's kind of the thing is like load line actually just sort of fakes an output impedance for the VRM. Um, so yeah, I'm not sure. So there's like multiple different approaches I could have taken to that, but that would require a bunch of testing and um, yeah, I don't really like it would just require a bunch of testing that I like I'm not going to do that on liquid nitrogen. Also, I have the scores. So don't see much point. Maybe if I really dialed in the voltage regulation, the card would run 2500-ish because again, if you give it too much voltage, it starts dropping frames. So evidently, like you probably want really tight voltage, like you maybe would really want super tight voltage regulation on these cards, but um yeah, I've like like that would require more time. And I don't know that anybody would be that interested, and it would really require quite a lot of time to like test. Hey, do I want, do I want less V droop but leave the power plane impedance, or make because the thing is the power board can compensate for the power plane. Well, it won't know what it's compensating for, but if you set the voltage regulator to monitor the voltage at the GPU core instead of at the output edge of the e-power, um, if it sees like if it's set to output 1.4 volts and it sees 1.3 volts at the end of the wires, it's going to bring the voltage up. But I honestly think that might actually just make the voltage regulation worse, if anything. It might not make it better. So it's like, yeah, I'm not sure. I've like that's one of the things where yeah, you'd need to do a bunch of testing on that. And at ambient, I don't think it's going to be super effective trying to do that testing because the card doesn't pull that much power. Like at ambient, the voltage regulation on the card is actually a lot better than what I had on liquid nitrogen. Like this 230 millivolts current peak to peak or max 270 at ambient, the card does 160, right? So there's like what 70 millivolts more peak to peak on liquid nitrogen on the card than at ambient. Some of that might be down to the multi-layer ceramic capacitors getting too cold. There's not really much you can do about it. You want the like, you want the memory cold, so you can't really like you can't selectively heat the multi-layer ceramics, but I don't know, maybe packing a whole bunch of polymers behind the because polymers don't care that much as far as I'm aware for about low temperatures. And I think tantalums also have relatively good behavior at like super low temperatures. So yeah, so like yeah, LN2 overclocking though. If I left it at stock clocks and stock voltage, I don't think this would have been that bad. So maybe the ceramics are fine. I wasn't really like the thing is I really was using the oscilloscope more to monitor that the card is actually rendering everything rather than paying too much attention to the actual voltage regulation. So um, yeah, maybe in the future, um, and maybe on a card where in like the thing is just like, what's the point in rebenching the card now that I have all the scores? Well, I guess if I revisit 3D Mark and Vantage with the 10900K, it would be kind of a waste of time though, right? Like that's kind of the awkward thing is like on one hand, I would be like I'd like to know, like, is there a better way to do this? On the other hand, I currently have one of the fastest GTX 1080s around, like yeah, and so do I care? Is another question. Um, what did I mention? So, I've already mentioned that the card is super easy to bench, right? 4 hours on liquid nitrogen, no complaints, no cold bugs, no cold boot bugs, nothing. Actually, no, there is if you run, and this is just general Pascal advice, if you have these cards at full pot, they won't boot at high voltages. You might have to drop like if you try to reboot the card at 1.5 volts, it won't reboot. You have to reboot at like 1.3 or something. So that's not really a huge deal. But yeah, maximum memory voltage 1.51 volts, which I think is consistent across all GDDR5X cards. Because I remember 1.51 volts being like the memory voltage I was running on my GTX 1080 Ti as well. So yeah, that's the max, like that's the memory voltage for max memory clock is just 1.51. Yeah. Oh, yeah. VCore doesn't really scale past 1.4 volts out. Look at this. Somebody actually put useful notes into the notes. Why didn't I read them? Yeah. So it doesn't really scale past 1.4 volt set, and that's 1.4 volts idle. So at load, it would actually dip below that quite significantly, I think. And card starts dropping frames if clock too high. Also, if just too much voltage, which is like that's where the oscilloscope helps so much because like you can't like it's like I wasn't noticing any like artifacting or like black screens or anything in the actual benchmark, but the benchmark would finish, the score would be like the score would go down, right? Like you'd clock the card up, you'd raise the voltage up for stability, and the score would go down, not up. And it's like, yeah, it's because the card is dropping frames, which is super weird. But yeah. Oh yeah, and I spent way too much time trying to figure out LOD because my NVIDIA inspector wasn't working, so I had to do NVIDIA Profile Inspector, which is like a totally different program that I didn't even know exist, so I had to like Google how to get LOD working, so that was fun. It's a good thing that these cards just, like that the card is so well behaved on liquid nitrogen. Um, yeah, oh, and then my last note is that 3D Mark 11 hates Ryzen, but I already mentioned that. So, yeah, like GTX 1080, great card on LN2. It's a real shame that miners have made these way too damn expensive. Actually, the miner-induced GPU shortage has led to basically all GPUs being way too damn expensive, unless they're completely ancient, which, to be fair, there's quite a few, ancient GPUs out there which are fun to bench. But I will say, like, the nice thing about the 1080 is it runs full pot. Like, it is so easy to run this, assuming that you don't have any issues with, like, the thermal paste cracking or anything, but at least for me with the thermal grizzly Cryonaut Extreme, I didn't have any issues with the thermal paste cracking or anything. Also, I forgot to mention the LN2 pod I was using is the Derbauer Raptor 4, and that wasn't a gift from Derbauer. I actually bought that. It's a great LN2 pot. I really like it. It's like, well, I don't know how it compares to like current gen LN2 pots because there's been like a lot of design changes, but between the LN2 pots I have, which is like I have a Raptor 4 and I have a Tech 9 Fat, so one of the rather like older Kingpin cooling designs, this thing is a lot faster. Like, well, no, this is just better. Like, it holds load better, it's faster to cool down, it doesn't need as much glazing to work properly. So, yeah. And that's it for the session summary, which the session summary is all like 125% of the length of the session. So that's great. 1 hour and 3 minutes, about a 4 hour benching session, but yeah. Like, it's a real shame these cards aren't cheaper these days because they're really fun to bench. I guess GTX 1060s would also be fun, 1080s fun. Well, 1080, 1070, 1060. I think the 1060s might be better behaved. If I remember, actually, it might be down to the fact that like 1080s are the like first card to release, right? Like if you remember Pascal, it was 1080 came out. Then I think the 1060 came out after that. And then I don't know when the Titan X Pascal came out. That would also be an interesting card to bench, but those things are stupid expensive. Also, you don't want the original Titan X Pascal. You want the little p, the Titan, because the thing with the so you have this thing. You don't want that. The VRM on that is trash. It is literally half the VRM that you get on a 1080 Ti. You will probably have to e-power that. Luckily, the e-power, like, it's not that hard to e-power NVIDIA cards. Because unlike AMD, NVIDIA doesn't have digital voltage controllers that throw a fit when you try to do anything to them. And there's not much point in benching a Titan XP, unfortunately. Right? Not many points to go around. It'll be interesting. I wonder what the fastest Firestrike run is. 2455. Room der Bauer. Anyway, I should end this video. So, yeah. 1080s are fun to bench. Honestly, if you want to e-power, or, well, if you're looking to learn how to do e-powers, I'd say the 1080 FTW is a really solid option for it. Like, because you can find these dead with the V-Core VRM exploded. So this is like a cheaper way to get a 1080 than an actual working 1080. You just have to source your own power delivery for it afterwards, because, yeah, there's going to be a crater. Like, the card doesn't have a fuse, so when that power, like, when the VRM fails, it does this. Very consistently, it does this. So, because there's nothing to limit the energy, like, after whatever component it is that fails, there's nothing to limit how much energy goes into that short circuit except for your power supply. And most power supplies are pretty slow to respond to, shorted out PCB components. So cards without fuses tend to end up with holes like this in them. Well, not really a hole, but craters like that in them. And yeah, also I wouldn't bother trying to like partially repair this, like, removing the short and getting the rest of the VRM running, it'll just blow up again. It's like the VRM, if the VRM worked properly in its full configuration, which is a 10 phase, it would be pretty decent. But with like one, it tends to blow up. Two, if you're trying to repair it, there's a decent chance you might not get more than you might lose 3 phases or more even. And if you do, the VRM very quickly goes into sort of like, I don't really want to run that. I wouldn't run that if I were you territory. Like, honestly, you could like pull the VRM off of like a old not reference, but like old direct CU2 cards from Asus have really good VRMs. Like, a lot of them have like a pretty solid 8-phase V-core. So if you want to power a 1080 with something, you can use that. That's like solid VRM that shouldn't be too difficult to find. Also, old EVGA classified cards are a great source of like a really, really strong VRM. A bit awkward to connect, but yeah. Anyway, I should just end the video at this point. Yeah, it's getting way too long. So yeah, that's it for the session summary for benching the GTX 1080 FTW on LN2 with the E-Power. Yeah, super fun card. And hopefully this was somewhat interesting and inspires you to bench, not necessarily 1080s, because these things are way too damn expensive currently. I'm lucky that I got my card. Actually, I've overpaid for it. I paid like 100 quid for the stupid thing. It's a dead card. Admittedly, now, if you want a dead 1080, they're like 200 quid, because people on eBay are insane. But yeah, so I'm actually pretty lucky to get mine for 100 quid. But yeah, hopefully maybe inspire you to bench something, cheaper than a 1080, because, yeah, there's plenty of other fun cards out there, but 1080s are definitely cool. So, I don't know, if you upgraded from a 1080 and you still have the card, like, why not? Unless it's reference. I wouldn't recommend doing this to a reference card. It'll maybe be fine. Probably want to strap a Delta fan to the VRM. Anyway, end the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store. You can pick up shirts, stickers, posters, hoodies, the usual YouTuber merch. Yeah, that's it for the video. So Teespring Teespring and Patreon links in the description. End of video. Thanks for watching. Goodbye.